Imagine a future where humanity has unlimited energy. Picture a world where the power of the sun is harnessed to its fullest potential, providing clean, renewable energy for everyone. This isn't just a dream, it's a vision that could transform our planet. No more fossil fuels, no more energy bills. Imagine the freedom and the possibilities that come with an endless supply of energy. Our reliance on non-renewable resources would be a thing of the past, and the environmental benefits would be immense. This is the promise of a Dyson Sphere, a hypothetical megastructure built around a star to capture its immense energy. Envision a colossal array of solar panels encircling the sun, capturing every bit of its radiant energy and converting it into usable power. It sounds like science fiction, but the idea has captivated scientists and dreamers for decades. The concept was first proposed by physicist Freeman Dyson in the 1960s, and it has since become a staple of futuristic thinking and science fiction literature. The sun is a giant ball of fire, constantly radiating energy into space. Every second, it emits more energy than humanity has used in its entire history. Tapping into even a fraction of this energy could revolutionize our world. A Dyson Sphere would be like a giant solar panel, catching all that energy and beaming it back to Earth. This energy could be transmitted via microwaves or lasers, providing a continuous and virtually limitless power supply. With that much power, we could achieve incredible things. Our cities could be powered entirely by clean energy, our industries could operate without polluting the environment, and our technological advancements could accelerate at an unprecedented rate. We could power our cities, our industries, and even our spaceships. The energy from a Dyson Sphere could enable us to explore the far reaches of our solar system and beyond, making interstellar travel a reality. Think about what we could do with a near-infinite power source. We could develop new technologies, improve our quality of life, and address some of the most pressing challenges facing humanity today. We could solve climate change, explore the galaxy, and create a sustainable future for generations to come. The potential is truly limitless, and maybe even contact other civilizations. The possibilities are endless. With the energy of a star at our disposal, we could reach out to the cosmos and discover if we are truly alone in the universe. But building a Dyson Sphere is a challenge of unimaginable scale. It would require advancements in engineering, materials science, and space travel that we can only begin to imagine today. Yet, the dream persists, driving us to push the boundaries of what is possible. The idea of a Dyson Sphere isn't new. It was first popularized by physicist Freeman Dyson in 1960. He imagined a civilization so advanced that they could harness the full power of their star. This concept quickly captured the imagination of science fiction writers and futurists. From Star Trek to Star Wars, Dyson Spheres have become a staple of science fiction. They represent the ultimate technological achievement, a symbol of a civilization that has conquered the stars. But is it really possible? Building a Dyson Sphere would be a monumental undertaking, unlike anything humanity has ever attempted. The concept itself is mind-boggling, requiring us to think on a scale that is almost incomprehensible. Imagine a structure that completely encompasses a star, capturing its energy output to power advanced civilizations. The first challenge would be gathering the raw materials. This isn't just a matter of mining a few asteroids. We would need to harvest resources on an unprecedented scale. We would need an unimaginable amount of material, more than all the planets in our solar system combined. The sheer volume of resources required would be staggering, and traditional mining methods would be woefully inadequate. Where would we get all this material? One potential solution lies in the very planets that orbit our sun. One idea is to dismantle Mercury, the closest planet to the sun. Its proximity makes it an ideal candidate for resource extraction. Its rocky body contains enough iron and other elements to form a substantial structure. By breaking down Mercury, we could obtain the raw materials needed to start building the Dyson Sphere. We would need to develop advanced space mining and manufacturing techniques to accomplish this. Traditional methods would not suffice. We would need to innovate and create new technologies. Once we have the materials, we need to put them together. This is where the real engineering challenge begins. This is where things get really tricky. The construction of a Dyson Sphere would require precision and coordination on a scale never before seen. We would need to develop self-replicating robots, machines that can build copies of themselves using the resources around them. These robots would be the backbone of our construction efforts. Machines that can build copies of themselves using the resources around them. This would allow for exponential growth in our construction capabilities, as each robot could create more robots, speeding up the process immensely. These robots would work tirelessly, assembling the Dyson Sphere piece by piece. Over time, this massive structure would begin to take shape, a testament to human ingenuity and the relentless pursuit of progress. The technical challenges of building a Dyson Sphere are staggering. This concept, first proposed by physicist Freeman Dyson, involves creating a massive structure that could encompass a star to capture its energy output. The sheer scale of such an endeavor is almost beyond human comprehension. We need to consider the immense gravitational forces, which would be unlike anything we've ever dealt with before. The gravitational pull of the sun is so strong that it would require incredibly precise calculations and engineering to ensure that the structure remains intact. The intense heat and radiation from the sun present another formidable challenge. The sun's surface temperature is around 5,500 degrees Celsius, and solar flares can reach millions of degrees. Any structure built to harness this energy would need to withstand these extreme conditions. And then there's the sheer scale of the project. Constructing a Dyson Sphere would require resources and manpower on an unprecedented level. It would be like building a skyscraper 1,000,000 miles high in the middle of a furnace with no room for error. It's like building a skyscraper 1,000,000 miles high in the middle of a furnace. The logistics of transporting materials and assembling them in space would be a monumental task, requiring advancements in space travel and construction technology. One of the biggest challenges is stability. A Dyson Sphere would need to be perfectly balanced to avoid being pulled apart by the sun's gravity. Even a slight imbalance could result in catastrophic failure. A Dyson Sphere would need to be perfectly balanced to avoid being pulled apart by the sun's gravity. Imagine trying to balance a structure that spans millions of miles, with forces acting on it from all directions. Imagine a beach ball trying to contain a bowling ball. It just wouldn't work. The forces involved are simply too great for any known material to handle. Then there's the issue of material strength. The materials we currently have are not capable of withstanding the conditions near the sun. We would need to develop entirely new materials, capable of withstanding temperatures of thousands of degrees and the intense radiation. No known material can withstand the intense heat and radiation near the sun's surface. The development of such materials would require breakthroughs in material science and engineering. We would need to develop entirely new materials capable of withstanding temperatures of thousands of degrees. This would involve extensive research and experimentation, pushing the boundaries of what we currently understand about material science. Despite the challenges, the potential benefits of a Dyson Sphere are too great to ignore. With access to all the sun's energy, we could power our civilization for millions of years to come. We could create a paradise on Earth, free from energy scarcity and its associated conflicts. Imagine a world where every home, every vehicle, every factory runs on clean, renewable energy from the sun. We could eliminate our dependence on fossil fuels, ending pollution and climate change. The Dyson Sphere could be the key to a sustainable future for humanity. But there's another side to this coin. Building a Dyson Sphere would require an unprecedented level of resource consumption and industrial activity. It could have devastating consequences for the solar system's delicate balance. The amount of energy a Dyson Sphere could capture is mind-boggling. The sun emits enough energy in a single second to power our current civilization for millions of years. A Dyson Sphere could potentially collect all of that energy. Think about what we could do with that much power. We could desalinate water to irrigate deserts, turning them into fertile farmland. We could power giant spaceships capable of reaching other star systems. The possibilities are limitless. With access to such vast amounts of energy, we could even control the climate, terraform planets, and perhaps even influence the evolution of life itself. The Dyson Sphere represents a turning point in a civilization's development, a leap from planetary species to galactic civilization. But with great power comes great responsibility. Building a Dyson Sphere would make us stewards of the solar system, with the power to alter it in fundamental ways. This raises ethical questions about our right to control such immense forces. What if we make a mistake? What if our calculations are wrong and the Dyson Sphere destabilizes the solar system? We could inadvertently trigger a cosmic catastrophe that could wipe out life as we know it. Furthermore, the construction of a Dyson Sphere could have unforeseen consequences for the delicate balance of the solar system's ecosystem. The mining of Mercury and other planets could disrupt gravitational fields and lead to unforeseen consequences. The short answer is, not yet. We are centuries, if not millennia away from possessing the technology and resources to even contemplate such a project. The challenges are simply too great for our current level of development. However, just because we can't build a Dyson Sphere today, doesn't mean we shouldn't think about it. The very act of imagining such ambitious projects pushes the boundaries of our scientific understanding and inspires us to reach for the stars. Perhaps one day, far in the future, our descendants will look back at our time and marvel at our audacity, our willingness to dream of such impossible things, and perhaps, just perhaps, they will have achieved what we could only imagine. The Dyson Sphere remains a symbol of humanity's potential, a testament to our ability to dream big and strive for greatness. While it may be a distant dream, it serves as a powerful reminder that there are no limits to what we can achieve if we set our minds to it. Perhaps one day our descendants will bask in the glow of a Dyson Sphere, their civilization powered by the harnessed energy of a star. Until then, the dream of the Dyson Sphere will continue to inspire us to push the boundaries of science and explore the cosmos.